Hello, we're going to be talking about powers and exponent laws. So we're going to just be going through the examples and agree with the notation. So read and notate this. It's simply saying x times x times x times x times x times x. 6 x's corresponding with the number of powers. Again, for factored form, the x is the base, 6 is the power. So this would be example 2 when it's asking for the expression in factor form. I wrote the expression in factor form and in the notation. The other two examples here, when we're asking for 2m divided by 5 and by 3, to write these ones in factor form as well. So we simply write down 2 multiplied by m, 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 n. So there's 5 n's, and there's 3 n's. It's 3. Each of the dots represent multiplication. Here with 2m to the power 4, the brackets encase the 2m together, so the 4 means that there will be 4 of them. So it will be 2m, 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 2m. So now we're going to move on to the next power for examples. So we're going towards example 3. So for example 3, we're asking for you to express in power form. So you count the number of variables, so there's 2 x's, so this one's squared, it's 3 y's, so that's going to be cubic. So this one's going to be 3x squared y 3. Now there's 9n, 9n, 9n. 9 and the n are attached together, whereas in previously the 3 is separated. So here the 9 would be also part of the exponent. In this case, we're actually going to need a bracket. 9 n power 4. I apologize if my 9 looks a bit like a G, because it's supposed to be 9. And this is supposed to be a 4. There we go. Alright, so now we're moving on to example 4. So this one here, it's asking to express each power of 3. So we're going to simply divide these by 3 until we get to 3. So for 729, divide by 3 once is 243. Divide it again is 81. Divide it again is 27. Divide again is 9. And divide again is 3. So in this case, it should be 3 to the power of 5. And we multiply by 3 once, twice, 3 times, 4 times, and 5 times. So, sorry, did I say 5? It should be 6. So 3 times 3 gives you 9, times 3 gives you 27, and then times 3 gives you 81. So we can actually just fill that into that one to the right now. So this is actually 3 to the power 4. And then from 81, we multiply by 3, get the 243. And multiply by 3 one more time, gets you to 729. So it's 3 to the power of 6. So just count the number of times at which we had to divide by 3, and then that will tell you about the power that is. And then I'm going to do the 5th example here. So the 5th example, it's going to ask us to simplify. So 6x to the power 7, multiply, we're going to apply the multiplication rule when we're adding the exponents. So this 6 will be 6x to 10, and then we're going to multiply by 4x. So same idea, be 24, and x to the power of 11. For b here, we have negative 36 divided by 3, and then we also have m to the power 12 divided by m to the power 9. So using the division rule, we're going to be subtracting these exponents. So first do the coefficients, so negative 36 and 3. So this should become negative 12. And then m to the power of 3. Over here, we have exponents. So in this case here, we're actually going to be multiplying the exponents with the other exponents. So this one here was x squared, so that'll be times 8, so it'll be x is 16, and y 5, times x is 40. And here, same idea, although with this time we're going to actually do this with 2 as well, so 81, and then x 16, and y 4. Okay, and here we're at 21, 3 times 7, and then m, we're going to add those together, so that's going to be 8, and n 6. Here we're going to multiply the top first, and then multiply the bottom. The numerator and denominators will be separated first, and then we'll put them together afterwards. So in this case, 5 times 8 is 40, then 10 is 9 plus 1, and n will be 8 is 2 plus 6, all divided by, the 2 has, this remain as 2. In this case, m will be 8, and then n will be 4. And once we divide this out, this should become 20, as 40 divided by 2. M will be squared, and n will remain as power of 4, because 8 minus 4 gives you 4. So it looks like it didn't move, but it's 8 minus 4. That's where we start at power of 4.